I'm like, hi.
All right. Good afternoon. Today I'm gonna solve one example for slider crank displacement analysis of slider crank. Then we are gonna talk about displacement analysis of four-bar mechanism. Four-bar mechanism has more steps to do than the slider crank. So follow the steps and make sure that you totally understand whatever I have done. I will be done to drive the equation. So for a slider crank, we are looking for displacement of the slider with S and not, and the theta 3, which is the angle of link 3. We derive this quadratic equation s squared minus 2as cosine of theta 2 plus a squared minus b squared. And to find theta 3, we are gonna use this equation. So now suppose for the slider crank with the dimension of A equals to 1, B, which is this side, equals to 2.5, at theta 2 equals to 30 degrees, which is somewhere here, for example. We would like to do the displacement analysis. So we are going to find theta 3 and S. So the length of the links, the mechanism are given, A and B are given, input angle is given. We are looking for S and theta 3. First, we plug in a quadratic equation to solve for S. Then after we solve S to plug in here, we don't need S here. We get two angles here, two angles from second equation, and find the matching pair. So I'm just plugging the numbers there. S squared minus 2, A is 1, S is variable cosine of 30 degree, plus A squared minus B squared. A is 1 square, B is 2.5. And set it equals to 0. This equation is going to change to 2 times s square root of 3 divided by 2 times s plus 1 minus 6.25 negative 5.25. So this is the quadratic equation by plugging the length of the links. You know how to find the roots for this. I just write the roots. S1 is 3.316. S2 is negative 1.584. So these are the location of the slider, or two possible modes. The slider is going to be on the distance of 3.3 on the right side, and negative 1.5, meaning that I should move in the left side. For the same angle of theta 2, which is 30 degrees. Next step is finding theta 3. For first node, for S1 equals to 3.316. First equation, S is 3.316 minus A, which is 1 cosine of 30 degrees divided by B, which is 2.5. It's going to be 11.98. Second equation, negative A, which is negative 1 sine of theta 2 dividing by B, 2.5. It's going to be negative 0.2. We are solving for theta 3, which is corresponding to first node. This one, 3.316 minus 1, which is A, cosine of theta 2, which is 30. Any question on this? So, if you use your calculator and find cosine inverse of 0.98, you will get theta 3 equals to 11.34. One angle is 11.34. Since it's a cosine, the other angle is theta 3 negative, whatever is this angle, negative 11.34. This angle is going to have the same cosine as this one. And for this angle, theta 3 is going to be if you use your calculator, you will get negative 11.34, and this one is 180 minus whatever is this angle, negative 11.34. 180 minus, it's going to be plus 191.34 degrees. So you have one angle, 2, 3, and 4. So you look at them and find the matching pair. The only matching pair is negative 11.34. So mode 1 has S equals to 3.316, theta 3 equals to negative 11.34. If you want to work with the positive number, if you negative, if this is the circle, negative 11, it's meaning you should move in clockwise direction, clockwise in this direction. We can move 11.34, so this is the angle that we have. If you want to deal with the positive angle is going to be this, which is 360 minus this. So we can say 360 minus 11.34, which is going to be 348.66. So these two angles are the same. Either we can say that theta 3 is negative 11.34 or positive 368.66 for the side. Three, four, eight. Good. Any question on this? I just did it for the first node with this S value. I need to do it for the second node to find the theta tree corresponding to this node. Second node is S2 equals to negative 1.584. Cosine of theta 3, just use this one. S negative 1.584 minus A is 1. Cosine of 30 divided by B, 2.5. You will get negative 0.98. And sine of theta 3 is negative A, negative 1, sine of 30 divided by 2.5, which is negative 0.2. It's same as, for this one, it's same as the mode 1 because it doesn't deal with the S value. And A, B, and theta 2 will be the same for both modes. So this one, still we get negative 11.34, 191.34. For this one, the angle that I will get is 168 point 164, and the other one is negative 168.64. Whatever I got here with the negative value. .64, negative 168.64. Which one is the matching pair? Say it again. You got 4 angles, 1, 2, 3, 4. So if you didn't get any matching point, meaning that you have done some miscalculation. But here I can see a matching pair, but you should just look at the other way of the angle. So negative 168. Negative 168 from 0, ground line, moving clockwise, go all the way, this is negative 90, this angle is negative 168.64. So the other angle is 360 minus this. So it's gonna be 360 minus 168.64. It's gonna be 191.36. So this is same as 199.36, and these two are matching pair. So when you look at the 4 angles, at the beginning you don't see any matching pair. But if you just look at the angle in the other way, you will find 191.36, which is same as the angle that you got right here. Make sense? So you should be careful on finding the matching pair. If you look at the angle and you really couldn't find any matching pair, it means that you have done some miscalculation. Go back and check your calculation. But you might get something like this, that you basically have the matching pair, but you should just change, look at the angles in the other form. Then I can ask you to draw the mechanism at its two nodes. First node. Pick a point. From that point, A is given, A is 1. By the angle of 30, you can reach to this point, point A. S is 3.3116. Just move in the positive direction, find 3.3116, connect these two. This angle should be 348, or this angle should be negative 11.34. This is how you can draw the mechanism at its first mode. For the second one, you are here, S is negative, you move negative 1.58 in the other direction, connect these two, this angle should be 191. Draw a line. If you measure this angle, it should show me 191 or something like that. All right. Any question about this? So these are the points that you should remember when you look at the slider crank mechanism. The unknowns which should be eliminated should be kept on the left side. If you remember, we were trying to remove theta 3. So we kept all terms with theta 3 in one side. I would like to eliminate theta 3. I kept all terms with the theta 3 in one side. I moved the other term to the right side. If I square both sides, add them up, I can get rid of theta 3. Because sine square plus cosine square is going to be equals to 1. So you can get rid of theta 3. I'm going to repeat that in 4-bar mechanism as well. Second thing which is important, sine and cosine inverse function are multivariable. So you have to work on these two equations at the same time and find the matching pair. Don't use only one equation and find theta 3 because it's a multivariable function. And if you couldn't find any matching pair, you should check your calculation. You have made a mistake somewhere. All right, 4-bar mechanism has more details and more calculation than this one, because we are going to end up with a nonlinear equation, and to solve that nonlinear equation, we need to apply a mathematical technique. So now, so when you are given with any mechanism, the first thing that you need to do, form the vectors. So I have 4 links, A, B, C, D. So I have 4 links, n is 4. So we are going to have 4 vectors. Link 2, I put the arrow at this point, at point A. For link B, you can put either at point A or point B. I put the arrows at point B. For link 4 or C, I put the arrow here, and for the ground, I'm going to have like this. After you form the vectors, you can label the angle. For link 2, the angle should be measured at the starting point of the vector in counterclockwise direction. Theta 2. For this length, I should measure theta 3 at point A. Length 4, I should measure at this point. Length 1 is ground, 2, 3, 4. So theta 2 corresponding to length 2, theta 3 corresponding to length 3, theta 4 corresponding to length 4. And length 1 is ground, it has the angle of 0 with the ground. So then look at this step. Constant A, B, C, and D. The length of the links are constant. They don't vary when the mechanism is moving. The variables are theta 2, theta 3, theta 4. I have 3 moving links. 4 and 3 moving. So I'm going to have 3 variables. And all 3 are angles because we don't have any slider. None are constant plus theta 2. I assume theta 2 is given. I'm solving for the remaining. Now I'm ready to write the vector loop equation. Find a point or a joint with 2 arrows ending to that. Joint P. I'm starting from the origin, which is here. I'm trying to reach point P through 2 different paths. Vector O to A plus vector AB. Let's stop here. Now start from O2 going through the other path. O2, O4 plus vector O4B. These 2 are equal to each other because they end up to point B. This path. Now, the rest is just the mathematical part. I'm looking at this vector loop equation. For each vector, I'm writing the x component. Vector O to A, x component of this, meaning this part. It's going to be the length times cosine of the angle, which is A cosine of theta 2, plus AB, length of the vector times the cosine of the angle. B cosine of theta 3, equality sign, O2, O4. O2, O4. It's D cosine is 0. D cosine of 0, or you can write only D. Plus C cosine of theta 3. The length of this link, cosine of theta 4 side. This equation is valid. From this, I can get 2 equations. One for x, one for y. In y component, just change any cosine term to sine. A sine of theta 2 plus b sine of theta 3 equals to d sine of 0, which is 0, plus c sine of theta 4. In this line, you can see those 2 equations. A cosine of theta 2, B cosine of theta 3, D times cosine of 0, which is 1, it's going to be D, plus C cosine of theta 4. Second equation, y component, cosine has been changed to sine, cosine has been changed to sine. D times sine of 0 is 0, C sine of theta 4. So we have two equations here. How many unknowns do we have? 2. So we should be able to solve for theta 3 and 4. So the rest is just a mathematical technique to solve the value for theta 3 and theta 4. Any questions so far? Again, when you write this one, you are almost finished by 50% of the problem. This is the keyword. The rest are the mathematical steps that you should follow to solve for unknowns. So theta 3 and theta 4 are unknowns. I'm gonna get rid of one of them, solve for the other one, then back to this two equation and plug in those numbers and solve the value for the variables that I eliminated. So this time I'm gonna eliminate theta 3. So same as slider crank mechanism, the variable which should be eliminated should be kept on the left side. I keep these two on the left side, I'm moving the other term to the other side. D cosine of theta 3 equals to D cosine of D minus D plus C cosine of theta 4 minus A cosine of theta 2. This term, when I move it to the other side, is going to be negative. D sine of theta 3 equals to D 0, sine of 0 is 0. I will get C sine of theta 4 minus A sine of theta 2. Why did I do that? Because I would like to eliminate theta 3. How can I do that? If I keep theta 3 terms on one side, it has cosine of theta 3, it has p sine of theta 3. If I square both sides and add them up, I can do this. You will see many terms because this has 3 terms that I'm gonna square them. So just follow each term that I derive. This term squared, b squared, cosine squared of theta 3 equals the entire of the parentheses should be squared. D squared plus this term squared, which is c squared cosine squared of theta 4. Negative a cosine of theta 2 squared is going to be positive when it's squared. 2 times this term times this term plus 2 dc cosine of theta 4. 2 times this term multiplied by this term. I have negative 2ab cosine of theta 2. 2 this term multiplied by this term, negative 2ac cosine of theta 4 cosine of theta 2. I'm done with the first row. Second row, it's easier because I have 2 terms. C squared sine square of theta 4 plus a square sine square of theta 2 minus 2ac cosine of theta 4 cosine of theta 2. This line I expand a square plus, I forgot plus here, b square cosine square plus b square sine square. I add them up. Right side plus right side for this plus right side for this one. Left side should be added. So b square, if I take this b square out of the parentheses, I will get b square times cosine square plus sine square, which is 1. I'm rewriting this part. Let me just do some simplification. Look at this term, CS squared cosine squared, and this term, CS squared sine squared. Summation of these two is same as summation of these two. I can take out CS squared. Out of these two, I will get cosine squared plus sine squared. The angles are the same, I will get only CS squared. These two, A squared cosine squared of theta 2, A squared sine squared of theta 2. Same logic, I will get A squared. I'm just rewriting the rest. Minus 2AD cosine of theta 2.
Is the bottom 2AC last as bottom right? It's
Yes.
supposed to be cosine or sine?
Cosine, both are sine. Thank you. Thanks for catching. 2AC sine, because I'm working on this one. Negative 2AC AD cosine of theta, negative 2AC cosine of theta 2, cosine of theta 4. Last term is negative 2AC sine of theta 2, sine of theta 4.
Shouldn't the A squared be positive?
A squared should be positive. Thank you. You will get this one. Look at this. B squared, D squared, C squared. It should be C squared. I have C squared. I don't know why. I got D squared plus A squared plus 2DC. Where do I have 2DC? Yeah. 2DC cosine of theta 4, negative 2AD cosine of theta 2. And negative of these two terms. Since both have 2AC, this one has 2AC, this one has 2AC, you can see what here I take out negative 2AC and I have the brackets. Alright. I'm gonna move B squared to the other side, it's gonna be negative, and divide both sides by 2AC. 2AC. So 0, because left side is gonna be 0. D squared plus C squared plus A squared minus B squared divided by 2AC plus 2DC divided by 2AC cosine of theta 4 minus 2AD divided by 2AC cosine of theta 2. And this term divided by 2AC, I'm going to have only the brackets. Minus cosine of theta 2, cosine of theta 4, minus sine of theta 2, sine of theta 4. since I would like to simplify this equation more, I define some intermediate variables. So let me get rid of this now. I define K1 as a D over A and K2 as a D over C and K3 as A squared plus C squared plus T squared minus T squared divided by 2AC. So if I do that, the first term is representing K3. So it's going to be K3 equal 0 equals to K3. Here, I cancel out these two and these two C, D over A. D over A is K1. K1 cosine of theta 4. 2A can be cancelled out. D over C. I define as a K2. K2 cosine of theta 2, and the rest I leave it there. Negative cosine of theta 2, cosine of theta 4, negative sine of theta 2, sine of theta 4. Negative. Negative. I just want to have less parameters. Just don't get confused by A, B, C, and D. I just read it. But we know that what is the value for K1, K3, K2. And now over there, I'm gonna move this to one side. It's gonna be positive. These two negatives are gonna change positive, and I keep them in one side. So it's gonna give me K1 cosine of theta 4 plus K2 negative K4. Cosine of theta 2 plus K3 equals to cosine of theta 2 cosine of theta 4 plus sine of theta 2 sine of theta 4. We call this equation Fredensson equation. I just move these two terms to the other side. I wrote this term first, then this term, then last term. Theta 4 is unknown. Theta 2 is noun, is given. It should be given. Theta 4 is unknown. And K1, K2, K3. All three are known because they are a function of A and B and C and D. So the only variable here is theta 4. So it should be solvable, but the problem that we have, here we have cosine of theta 4 as well as sine of theta 4. We have nonlinearity in this equation. So we should just use a technique to solve, to get rid of this nonlinearity. Any questions so far? We have started from vector loop equation. We wrote x component and y component of this equation. You know how to do that. Then we try to get rid of theta 3. We kept theta 3 one side. We moved other terms to the other side. We squared. We add them up. We just did some simplification to simplify the equation, and we end up to Ferdinand equation, which is this one. Any question? Good? Alright. Next step is solving this. We are going to find theta 4 from that equation. We are using the technique of tangent of half angle. This is the mathematical technique that we are going to use to solve this. If I have an angle theta, we can prove, the proof is going to be on the last page of this slide. It's very simple. I just want to save time. I don't prove that. I don't show it in the class. So the cosine of any angle is going to be 1 minus tangent square of half angle, half of this, divided by 1 plus tangent square of half angle. And sine of theta is 2 tangent of half angle, 1 plus tangent square of half angle. This can be proof. For example, if cosine of 60, if you are looking for the cosine of 60, it's going to be 1 minus tangent square of 60 divided by 230, 1 plus tangent square of 30. If you do math, you will find it's going to be 0.5. This is what I mean. So how can I use this? I define a variable like t as a tangent of theta 4 divided by 2. I have angle of theta 4. I define t as a new variable which is a tangent of theta 4 divided by 2. So if this is true, then cosine of theta 4 is 1 minus tangent square of theta 4, which is t. 1 minus t squared divided by 1 plus t squared. And sine of theta 4 is 2 times tangent of half angle, which is 2 times t, 1 plus t squared. T would be tangent of theta 4 over 2. Sine of theta 4 is 2t divided by 1 plus 2 squared. Cosine of theta 4 is going to be this. Now, in this equation, wherever you see cosine of theta 4, replace that with that new equation. 1 minus t squared, 1 plus t squared. Here. Minus k2 cosine of theta 2. I don't have any theta 4 plus k3 equals to cosine of theta 2 times cosine of theta 4, which is this term. And last term, sine of theta 2 times sine of theta 4. Now, in this equation, we have only t as a variable. The other terms are none. I multiply both sides by 1 plus t squared, k1. This time 1 plus t squared, I will get 1 minus t squared. This one, I should multiply this by 1 plus t squared, minus k2, 1 plus t squared, cosine of theta 2, plus k3, 1 plus t squared, equals to 1 plus t squared can be cancelled out with this. I will have this times this one. Same thing here, 1 plus t squared is going to be cancelled out. I leave only 2t terms is going to be there. If you look at this equation, the only term that you will see is t squared and t. So I can change it if I simplify, do some simplification. I can end up to this quadratic equation. A t squared bt plus c, where I don't show the steps, but A is going to be negative k1, negative k2, cosine of theta 2, plus k3, plus cosine of theta 2. B would be negative 2 sine of theta 2, and C is going to be this. So how can we solve the quadratic equation? It's going to be negative b plus and minus s square root of b squared minus 4ac divided by 2a. And nature of solution, if inside the square root are positive, we can get two distinct assembly modes. If inside this one it's 0, we have one mode. You will see it's going to be the locking position. And if it's negative, we don't have any possible modes. So t is not the value that we are looking for. We are looking for theta 4 and theta 3. The value that you will get from t from this equation should be back to this equation. T equals to the tangent of theta 4 over 2. So tangent inverse of t is going to be theta 4 divided by 2. So theta 4 is 2 times tangent inverse of t. I could find the first angle, theta 4. Do it for the second mode. If you have two distinct modes, find the second mode, which is theta 4 2. I am done with the theta 4. How can I find theta 3? Back to this equation. I said cosine of theta 3 is this equation. D plus c cosine of theta 4 minus a cosine of theta 3 divided by d. And sine of theta 3 is coming from this equation. D is 0, sine of 0 is 0, c sine of theta 4 minus a sine of theta 2 divided by d. Whatever angle you get from here for the first node, you plug in here. You find a value right here for cosine of theta 3. Use your calculator, you will find two angles here, theta 3 and negative theta 3. Do the same thing here, you will find theta 3 and 180 minus theta 3. Compare them, find the matching pair, and report that as a first node. Node 1, theta 3 1, theta 4 1. Repeat this step for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, theta 4, 2, and you will get mode 2. Theta 3, 2, and theta 4, 2. And we are done. If you couldn't find any matching pair, means that you have made a mistake. So if you good calculation. All right, we continue on Wednesday class.